Anyway, moving on from my Canadianness. Today we're going to do finding the area between two curves. So instead of integrating between the x-axis and a curve, we're going to go from curve to curve. What? It's going to be incredible. All right, how do you think we might integrate if we weren't enclosing the area with the x-axis?
Well, with that curve you just told us to use.
Or
the y-axis.
the y-axis. Or another curve. I told you, I know, I gave it away. But I didn't tell you the y-axis one. All right, solve the following integral.
Oh, I don't remember how to do this. Is this the one where you do like
Find the
like
derivative.
f of 3?
I find the integral, x to the fourth over 4, minus x squared, evaluated from 5 to 2,
Yes.
which tells me 625 over 4 minus 25. What's up?
Hi, I came for the tests.
These ones. Did you already get the key
No, but I can do it again.
for that one?
Yeah.
It should be in there. Yeah, they'll like to not have their 0. Okay, and then 2 to the power of 4 is 2, 4, 8, 16 over 4, which is 4, minus 2, 4. It's a 0. So it's just going to be this, which is 625 over 4 minus 100 over 4, which is 525 over 4. Amazing. You find it? That's a little concerning though.
Or you can give me one and I can do it and I check it.
Sure. How many of you got it? How many got it?
Go to what?
That answer, girl.
You walked us through it.
But, okay, fine. I was hoping you had done it ahead of time. Whatever. All right. Graph the function f of x equals negative 1/2 x squared minus 2x plus 4. And then find that value. Okay.
So how do I draw that?
How do you draw that? Well, if x is 0, it's going to be 4.
How do we know that?
Because I put in 0.
So I plug in 0 where?
Okay.
I like the ones where
0 al cuadrado?
You know what? I don't feel like doing this by hand. I think we should just look at the graph.
No, Mr. Brad, if you get a question like this deep, it's just the one thing we do.
Nah.
Let's do it by hand.
and also like the ones
I don't want to. I don't want to complete the square.
Brad, what are we doing, man?
I don't want to complete the square.
No,
I don't.
Mr. Brad, discipline, man.
I don't feel like it.
The pain of discipline or the pain of regret. You choose.
What? What are you?
What the heck is that? Mister?
I don't feel like doing.
What are you doing? I don't feel like being in
You're
class
so
when
part-time
you're
today.
This mean in Canada?
Part-time Brad.
Oh my gosh! Fine. You know what? Let's go over here.
No. Can we do that in the text?
Sometimes,
No, of course. Esta no te voy a ofrecer.
guys.
Our text.
La verdad no tengo la energía para hacer nada y por mí que no hagamos.
Yo ya estoy espacio. Sí, ya hagamos esto.
I don't want to complete the square because the truth is, I don't think you guys remember how.
I don't know what that square is.
Exactly, and I don't want to teach it because it's pre-calc. So
So just do it and we see and then we'll get it.
I would get the point negative 2, 6. I'm going to have one over here like negative 5.5, and another one at roughly 1.5. And so that's what I graphed. Roughly. It's not quite right. It should go here and here.
My grandfather fought.
Yo estoy haciendo se le está abriendo los brazos que no he hecho.
This is the primer part. No la tengo.
Por de otro canal de
All right, there we go. Beautiful picture.
menos alguna
Sí, tu hermana perdió.
Using one color, shade the region. Guys, believe it or not, I already know this stuff. So if you're not going to listen, I don't need to do it.
You're such a big meanie.
No, you guys just won't shut up.
Please, do your Zoom
I am filming a video, and now it's immortalized about the fact that you guys aren't listening.
You know what's also immortalized? Your
Hi,
sassy
pobrecita.
Hi, pobrecito.
Exactly. All right, we shaded it. Look at us go. Woo!
What are you gonna do on Friday? Nothing. I don't really want to go.
7.6. All right, now let's do the integral from -5 to 0 of fx dx. Let's hope.
Negative 1/3 x. No, x. Negative x to the third 3. Es que esta clase no solamente Sí, es que
Over 6,
Why would it be 6?
because it's 1/2 times 1/3. Minus x squared plus 4x plus c, but I don't really care about c actually because I'm evaluating it from 0 to -5. We love this. What happens if I do it at 0?
It does.
It's all just 0. Minus
0.
-5 cubed is going to be -5 cubed, which will be positive 125 over 6. Minus 25. Minus 20.
But Mr. Brand,
What's up?
when it's like
Not
odd,
plus 20.
isn't it when it's an odd exponent?
Yes, it is plus 20.
It's definitely minus 20. Plus 4 times -5.
Ah,
And for a negative exponent, the negative stays. So -5 times -5 times -5 is negative 125 times the negative in front.
oh my
But
god.
it's an odd
Let's
exponent.
try.
That's why it was negative. And there's 4 negatives because there's 3 from the cube and 1 in front. Got it. All right, so minus 125 over 6 minus 45.
So,
That's gross. I don't want to do it.
so let's
Where's my calculator? I got to go 45 times 6.
Yay! When you do the squiggly line or the straight line, do they mean the same thing?
Sir, are
No,
we
una es integral y la otra es
It's 290.
It's 290.
supposed to know how to grab that without using it?
Pauli no estudies.
Ya, ahorita la toalla. Si no sabíamos hacer esa, we are so fun. Yo toda la vida escribiendo siempre la squiggly line. O sea, tengo problema de dictation serio.
And I would get 24.16 repeating.
Creí que era solo que andaba, pero no la squiggly ya. Era su short.
All right. Let's use a new color.
The hat. Why?
Because graph the function g of x, 1/2 x plus 4, on the same grid. Well, it's going to go through here. And I have a slope of 1/2. So just like that.
Why is that?
A slope of 1/2.
How do I know what I
And why are you putting that
It literally says 1/2. Right there. It literally says 1/2 x plus 4. Okay, so now that I've got that, then I'm going to shade it, I think, right? Use a different color, shade the region below. So we're going to shade this part. Amazing. And then we're going to find the integral from 0, or -5 to 0, of 1/2 x plus 4 dx. So I get x2 over 4 plus 4x evaluated from 0 to -5, which is nice because 0 is just 0, minus -5 squared is 25 over 4 minus 20, or 80 over 4,
Mr. Brand,
because 20 would be 80 over 4. Yeah.
did you already distribute the negative?
Nope, it's right here in front.
Then why is it minus?
What's minus? This part? Because it's -5. 4 times -5. All right, that gives me negative 55, which will become positive, so it's going to be 55 over 4. Amazing.
And that equals 13.
Yes, it does. Great. How do you suppose you would find the area of the region that is located between the two graphs? Right there.
Area of the first minus area of the second.
Exactly.
Where?
This area right here. So what I would do is find the area of the first one, the blue one, minus the area of the green, which would leave me with this area here. So that's exactly what I'm going to do. We're going to say area of the first. Wow, that's a fun of. Of the first minus area of the second. Which is, what was it, 24.16 repeating, I believe, minus 13.75. We'll just change that 0.6 repeating into a 0.7 to make our lives easier. And that'll be 2, 4, 0, 1. 10.42. Amazing. Does that make sense?
Yes.
Yeah?
I don't know how to like subtract.
You can't subtract? Like that.
Yes.
Well, you and I can talk about that later. All right, now find the value of the definite integral below if we know that f of x and g of x are these two things. Okay, well, if I want to do that, I'm going to find the integral from -5 to 0 of, and I'm just going to subtract these two functions, -1/2 x squared minus 2x plus 4, minus, are you guys okay if I distribute the minus into g of x right away?
No.
So it's -1/2, or minus like half x, minus 4 dx. Could I simplify any of that? Yes, so I should. There's no other x squared, so -1/2 x squared, but I can combine these, -2x and -1/2x, negative 5 halves x, right? -2 minus another half.
-2 and 1/2.
Yes, in other words, you're adding them. And then we've got 4 and -4, which just goes away. Those are gone. And so then I'm going to do dx of that. We good so far? Amazing. So, integrate. So it's going to be -1/2 x cubed over 3 minus 5 over 2 x squared over 2, evaluated from 0 to -5. But let's simplify that first because that's really ugly. X cubed over 6 minus 5x squared over 4, and evaluated from 0 to -5. Nice and easy. When we put in 0, it's all just 0. Minus, now we plug in -5. -5 cubed is -125 times -1 is +125 over 6. Minus, -5 squared is 25 times 5 is 125 over 4. You writing it? Didn't think so. So I can either put those both over 12 and figure it out as a fraction, or I can type this in since our previous one here was done as a decimal. Let's put it in our calculator. Technically, you should. Technically.
Or this.
And I get 10.416 repeating. Or 10.42 as we had before. Oh my gosh. What do we notice?
They're the same.
Samesies. We haven't got to write samesies for so long. What's up?
Since like 6.3.
Well, it's technically negative. So it becomes positive. So you're not wrong, but you're also not right. All right, it's samesies. This brings about the general way we're going to find the area between two curves. So the area between f of x and g of x, where they're just any old functions, is always going to be the integral from a to b of f of x minus g of x dx, where x equals a and b are the x coordinates of the intersection. So the x coordinates of the intersection of f and g. So it's where those two functions are going to intersect. Yes. You don't have to ask. You have never had to ask.
That's where you're the best.
Apparently. Find the area of the shaded region R that is... Yeah. So all this means is that your bounds on the... Your bounds are A and B, which are like, if I look at this one, it would be your intersection. So like it'd be A and B here. And then it's the top function minus the bottom function. So f of x minus g of x. Okay?
The actual function.
Yeah. So for, like we're going to do it together here. Okay? So this is very easy to see that this one here is 0. Right?
And the other one.
The other one here is 2 because it's graphed for us. Normally, how do you think I would find those? Yeah, I would plug it into the calculator or solve it algebraically, depending on how hard it is. But basically, I make these two equations equal and solve for x. And the intersection points are going to be the ones that we integrate between. Okay, so we're going to integrate. So r will be the integral from 0 to 2 of the top function, which is which? Sine in this case. Yeah, we could call it a, but sine in this case. So sine of pi x minus the other function. Can I distribute the negative? Yeah, right? So it'd be negative x cubed plus 4x. Right? I'm just distributing that subtraction. And then it would be, of course, dx. Now, technically, I need to do a u sub.
What?
Who can see the u sub?
We need to do.
We need to be able to have the license to integrate for all of it.
I need the license to integrate for the sine of pi x. So I can do it because I'm smart and realize I need a 1 over pi in front, or I can do the u sub. I'll do the u sub right now to help you, because I know at this point, you're going to need to do the u sub most of the time, right? Until you've done a whole bunch of questions with u sub, you're probably going to need to do a lot. So anyway, let's split this first. So this is going to be from 0 to 2 of sine pi x dx minus the integral from 0 to 2 of x cubed. Oh, this is awkward. I shouldn't have distributed that because now that I'm subtracting it, it would have to put it back in and be minus 4x because I went back to the subtraction. Or I could put plus and do minus and plus. But either way, if I'm going to pull out that negative to say I'm subtracting the whole integral, I need to also put it back in. Does that make sense, or have I lost you? Basically, I should have not distributed it here. Okay. Now, in order to do this one over here, I'm going to do that u sub. So u sub is the inner function. So pi x, which means that du is going to be pi dx. That means I am missing a pi. So I'm going to put a pi here and a 1 over pi on the outside, which is 1, right? I'm allowed to multiply by 1, and I effectively multiplied by pi over pi. I just split the pi over pi into 2 separate parts, just like we did before. So I put the pi on the inside because now I can change that 1, right, into u du. So I've got 1 over pi, integral from 0 to 2 of sine u, and then my du, pi dx, is there, so du. And I'll show you that. Let's highlight it. So here, my du needed pi and dx. And then the u was pi x, and so it was just this inner part. So you can see that I've converted everything to u's. Okay? If not, you got to come see me later, especially if you guys were some of the people that missed class. Okay, so minus the integral from 0, that's a terrible integral sign, but oh well, of x cubed minus 4x dx. And now can I integrate both of these? I deleted the prettier one. Yes, I can. So this is going to be 1 over pi of negative cosine. And instead of writing u, I can undo the u, right? So what is it?
The U is 5.
pi x. So I'm just going to put that pi x back in there. And I evaluate that one from 2 to 0.
You don't integrate that inside.
I did.
You don't have to multiply.
That's why I've got this 1 over pi out here, right? Right? I had to create the license to integrate or the u sum.
Continue.
Integral from 0 to 2 of x to the 4th over 4 minus 2x squared, because it would be 4x squared over 2. 4x squared over 2 just becomes 2x squared. And that's also evaluated from 2 to 0. Okay, running out of room. So then I need to go negative cosine of 2 pi over pi minus negative cosine, so plus cosine of 0 over pi.
You plug it in.
Yeah, I'm just plugging in the 2 and 0. Then I'm going to plug in 2 and 0 on this one. Oh, I accidentally drew the integral again. I apologize. Should have just been this. My bad. So minus 2 to the power of 4, which is 16 over 4, which is 4. Minus 2 times 2 is 4 times 2 is 8, so minus 8. Minus 0. Right? Because when I plug in 0 for x, it just doesn't do anything. So what is cosine of 2 pi?
2 pi over
1, right? So I'm going to get negative 1 over pi. Cosine of 0? So 1 over pi. And then 4 minus 8? Negative 4 minus 0?
minus 4.
Minus negative 4? Plus 4, right? Minus negative 4. Perfect. What happens to these? Oh my gosh, it's amazing. It's just positive 4.
So the area is 4.
The area is 4.
All that to get such a pretty number.
All that for a pretty number. It's almost like I worked really hard to make sure that it was pretty for you.
Oh my god, can I go to the bathroom now?
So cute.
Always.
I know you said you were not
If I'm really honest, it wasn't me, it was someone else.
It was ChatGPT.
Can we do
But no. I made these notes way before
8
ChatGPT.
centuries old.
It was.
I made these notes with Carter like,
I think we should take
oh,
a
I don't even remember. Like when I first started teaching 20
can we
years
take
ago.
like a 5-minute break, 2-minute break, 2 minutes.
Can we take a 5-minute break? Let's see.
2 minutes.
No, it's Wednesday and we've only got 2 left.
Can I?
No.
Why am I super tired?
We're gonna do one more first,
One more and a break.
if we have time.
That's like
But can I go talk to Andres?
Go. All right, picture to the right of the graph is f of x, which is this grossness. Amelia, you can do it. I believe in you. And a line L, which is tangent to f of x at the point 0, 3. So right here, this is tangent. That's our tangent line. Find the region R. Okay, that's easy. R isn't even the new stuff we did today, is it? What is R? It's just the integral of which function?
F of x.
Yeah, of f of x, right? We don't even care about this line. We don't need it, right? Because if we look at it here, right, it's just underneath this curve and the x-axis. Perfect. So we're going to integrate from, what's this point? But we don't want to guess. So what we need to do is we need to take this equation and graph it. This would be a calculator question. So I would graph this, okay? Or they would tell me what it is. That's the way it's going to work. So when I put this into my calculator, I did it already, 1.373, because I thought we might be short on time today because it's Wednesday, to 0, because we can see I stop at 0. Okay? Of just that first function, so that is x cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine x, and then all dx. So, if it's a calculator question, what could I do?
Use your calculator.
I could use my calculator.
Wait, where'd you get that number?
So, it's the integral, which number?
Or did you get 1.3?
Okay, I got it because I did this. We did x cubed divided by 4 minus x squared divided by 3. Whoa, there we go. Minus x over 2 plus 3 cosine x. And I just went and found that point. Negative 1.373. Okay? That's all I did. And this goes from negative 1.373 to 0. And now that we've already written out the function, let's make it easier on ourselves. Let's call this easier even. Let's call it f of x. I can just integrate f of x dx. And it spits out my answer. Okay? So, 2.903. Yep.
And then you just plug that into the calculator and you code it.
You would just literally put this in the calculator, which is effectively what I did, and you guys are allowed to use Desmos, right? So you define the function, and then you integrate from those bounds of fx dx. There's your answer. All right, now let's look at the trickier part. Find the equation of line L if it is tangent to the graph of f of x at 0, 3. All right.
Can you scroll? No, it is not.
So I got to do my pot first,
Oh my God. Can you scroll?
and then I need my SOT.
Where did you get 3?
It gave it to me, 0, 3.
But like, yeah, then you can see both.
All right, so now I'm going to have to find the derivative. So f prime, let's see, if this is the original, it would be 3x squared over 4
Oh my gosh.
minus 2x over 3 minus 1/2 minus 3 sine x. Yeah. Yeah.
And then we have to do
And then I'm going to plug in f prime of 0, which is 0 minus 0 minus 1/2. Sine of 0 is 0. So it's just negative 1/2. Now I can write out my line. Y minus 3 equals the slope. Technically x minus 0, but I don't need to write the x minus 0 part. So once I've got that, I'm going to want to put that into my graph so that I can find the other intersection point, right? So I'm going to scroll up just for a second, because now I'm going to need to find this intersection. This one's easy. This is at 0, 3. This one I need to find, right? So I guess maybe I'll write these in. This was negative 1.373. Yeah, but the next part is that I'm going to find what ordered pair other than 0, 3 does the graph line L intersect with the graph f of x.
Can't we just
Well, because
plug
I'm foreshadowing what are we going to need.
Can't we just plug in the line into the calculator?
That's exactly what we're going to do.
Yay!
So we're going to go y minus 3 equals
Negative 1/2
negative 1/2
x.
x. And we're looking for this one, right? We already know this one's 0, 3. So it happens at 3.3898. So it'd be like 3.39. So we're going to say that that happens at 3.39, and it said the whole point. So 1.305. I know, right? Now we're going to find the region of S. Now this is a little bit trickier because when we look at the region S, it's now below the line above the other curve. So we got to do that subtraction thing that we just learned, right? So it's going to be the integral from 0 to 3.39 of our two functions subtracted. Which one was on top again? The line. Now, unfortunately, that means I probably should change this line to be in y equals form. So it's going to be y equals negative 1/2 x plus 3. Okay, so that's the one I'm going to use first. Negative 1/2 x plus 3 minus the whole other function, which was x cubed over 4, x squared over 2, x over, no, it was x squared over 3, I think, wasn't it?
Yes.
Yeah. Minus x over 2 plus. All right, and then I need a big set around everything here that is dx. right? So this first part here was the line, which was above, and this part here was our curve. And because the line was on top, that goes first, and because this was on the bottom. Now listen, I'm using top and bottom right now. The way that's always going to work is further away. So this one is further away, and then this one. That'll make more sense in the next couple lessons. Okay, so then I just put that into my calculator. So I can do that really easily here by saying, hey, instead of graphing it this way, we'll say that this is g of x, and it equals negative 1/2 x plus 3, because now when I'm up here, I could just integrate, well, other way around, g of x minus f of x.
And you have to change that for like.
Oh yeah, and I got to change the bounds. Thank you. I was like, yeah. I was like, that doesn't look right. It shouldn't be negative. 0 to, what was it, 3.39? 3.39? And so I get 6.98. So this is 6.98. Amazing.
That's enough for today.
No, it's not.
Oh yeah. You still want
Guys, we got one more. We can do it. We only got like, what, 10 minutes?
Oh, like
We have for the other class. No,
We have 9 minutes. We can do it.
no, it doesn't. I beg you. I beg you.
All right. Pictured to the right of the regions R and S. Yeah. So we've got these two graphs. Identify the points of intersection.
But Mr. Bradley, would definitely be a calculator question.
This will definitely be a calculator question. Yes.
And we don't even have how to integrate.
So f of x was 1/4
Plus sine pi x.
sine of pi x. Perfect. And g of x?
4 to the negative x.
4 to the negative x. Okay.
There are a lot of points. No,
But
we have to put some intersection.
we're only looking at like this little piece, right?
Yeah, we're looking at those.
So these two are the ones we care about.
Zero.
So I'll let you guys write those down, and then I'll get you to help me write them down.
Punto 18.
Matias.
No,
Pedro Juan.
Mr. No.
All right, you guys got them?
No.
Okay, so
0.8. Just go back. Let me see the top of this.
it was 0.
18. No, but it's gonna have
Let's do more decimal places.
7-8.
1.
Okay, 1.78. Just because I think it'll be good to do that. And then it was 0. What?
781.
781. Okay, we'll do 3. And then
1.
that was amazing. 1.
0.25.
0.25. Perfect. Where this one here is going to be A, this one here is going to be B.
Okay.
Amazing. All right, now find the region of R. Now here's what you got to be careful of. Look at this. Which function is on top here?
The pi one.
If you need to, we can go back and look here. So it's the black one, which is,
X, negative x.
yeah, so it's this 4 to negative x, and then the bottom one is the sine one. So that means that for R, we're going to integrate from 0 to that 0.178 of the top function, which was 4 to the negative x, minus the bottom function, which is the f of x. So 1/4 plus sine of pi x dx. And thankfully, because we define them this way in here, we can just write it out, right? So we got to change these bounds from 0 to 0.178. It was g of x first, so g of x minus 4x is, oh, real small, 0.065. 0.065. So that's R. Then we're going to find S. What do you notice about S?
They flip.
They flip. Now f of x is on top and g of x is on the bottom. So we're also going to need to change the bounds. So it's going to be from 0.178 to, I think it was it's to 1, right?
Yeah.
Yeah, to 1. And we got to switch them around. So it's going to be 1/4 plus sine pi x minus 4 to the negative x dx. And now we need to put that into our calculator. Which for us, if we're using Desmos, is really easy because I literally just switch these, right? F minus G.
What?
Yes. And the bounds need to go to, there we go. I was like, why won't it let me click? 0.178, 21. And we get 0.410. 0.410. All right. So the last step, find the area of the unshaded region bounded by the graphs of f and g in the x-axis. Okay, this is where it's a little bit awkward.
So we're going at it from 0 to.
This should say from 0 to b. Since it doesn't, we're going to have to do a little bit extra work. It'll be great.
What do you mean from 0 to b?
I'll show you. I'll show you. So for now, it's pretty easy to think about, okay, the total area is just going to be that integral from 0 to a, right? That first point of, it was just the first function, right? Fx dx. I think, wasn't it? No, wait. No, this one was gx minus fx, sorry. No, wait, it says the unshaded region. So it's actually even different. It's just this piece, which would be under f of x.
But
It's the
also
difference
under
between R and
S.
S.
But it's only under f of x. The next section of it, which is from a to b, this is only going to be under g of x. So then we're going to add to that the integral from a to b of gx dx. Now here's the part that's actually missing. Are you ready?
C.
Yeah, we got to go from b to c of, let's go take a look at the graph. And let's look at it for real here.
So it would be
If I look here, which graph is, like, what's this little piece here underneath?
0 to that is just
Which one is it? Is it f of x or g of x?
that is
G of X.
That's f of x, and it's going to be from 1 to 1.08. So it's just a little tiny piece, but it is there, right? So we should include it. So in this case, we're going to, let's put a little note over here. C is 1.08 for us. Okay, and that would be just f of x if it's not g of x, I guess, dx, right? Because basically, if we go up here to look at it, this is this little tiny piece there, where we now called that c. Okay, are we good with that?
Yeah.
Awesome. So let's write out what that means. This is going to be from 0 to 0.178 of fx dx.
Can you show your graph again?
I will in 1 second. Let me write this out first. Okay, let's write this out and then we'll look at the graph. To 1 of gx dx plus the integral from 1 to 1.08 of fx dx. Now, because we have like 30 seconds left, I'm going to tell you what that answer is when we put it in our calculator. I think you guys know how to put that in your calculator. We've done it a bunch already. So when we put all of that together, we get 0.4862. Okay? And now I will show the graph, yes. Now, for the interest of completeness, we also want to mention that the other way that we could do this, I'll try and do this in a different color here, is we could simply do, because we already know S. If we didn't know S, this would be about the same amount of work. But because we know S, to get this area here, what we could do is simply find the area underneath the curve of f of x from 0 to point C and then subtract S. So, to write that one out, we could say, or it would be the integral from 0 to C of f of x dx minus the area of S, which we found up here, which was 0.41. 0.41? Yes, 0.41. And so then we can work that out, and lo and behold, we will get the exact same thing. So that is another way we could do it, which in this case is probably easier because we know S. If we didn't know S, then it's about the same amount of work. It's still technically a little bit easier, but not much because finding S was a little bit more work. And then we'd have to find the 0 to C and then subtract it. So it's, because these ones are slightly easier integrals to find, I would say it's about the same amount of work. But they do both work, so we could do either way.